Namaste Coders, I hope you are fine. So we are now solving the problems from LeetCode 75. So in this series we have solved all the problems, all the first problems from topics, all the topics, right? So now we are started with the second problems of the topics, and we have solved the problems from prefix sum, hash map, and all the previous topics, and now we are solving the problem from binary tree DFS. So the problem is leaf similar trees. Along with this LeetCode 75 series, we have started a series of solving LeetCode problem of the day, and I have uploaded the today's video. You can go through the video and check out the solution from LeetCode problem of the day. Along with this, one more thing, I have created a WhatsApp group for the coders, right? So if you are a coding enthusiast, you can join that WhatsApp group. So where we can discuss multiple things, including the regular doubts, algorithms, multiple things about the industrial trends, what is happening there in the coding world, and also we can start some good projects for like our resume for freelance work. Also we can do something. Also I will share some job openings. If there is anything inside our industry, inside our company, we can share. Like, there are multiple use cases for a WhatsApp group, right? So you can join that group. It's of course free of cost. So let's start with the video. So the problem is leaf similar tree. So the leaf similar tree is a tree where the leaf are similar in a particular order. So this tree have a leaf similar tree. Let's say this is something 6. Let's say here is 5. Then here is not 5. Here 7. Right here 4. Here 9. And this is 8. This is also a leaf similar tree because these all are the leaves and they are in a same order, right?
What's up, मामा?
जा रहे हो क्या?
मेरा कुछ था क्या यहाँ पे?
बैग रखा है?
बस बैग ही था ना, और कुछ नहीं था ना? हाँ, वो तो ले लिया। तू क्या कर रहा है?
सॉल्व।
कौन सा है ये?
लीफ सिमिलर ट्री।
इसी पे क्यों कर रहा है?
अरे वैसे ट्राई कर रहा हूँ समझाने का।
कौन सा ऐप है ये?
ऐप कुछ नहीं है, वो तो पैन करके है, उससे आप लिख सकते हो।
इसमें आता ही है?
इंस्टॉल करना पड़ता है। So sorry guys. So yeah, I hope you understand what leaf similar trees are. So how can we solve this problem? So we can do DFS, right? And whenever we encounter a leaf, we will store that leaf in a queue, right? First of all, so there are 2 trees, right? So in the first tree, we will store the leaves in a queue. So we will do a DFS, and whenever we encounter a leaf, we will store in a queue. And then we do a DFS for the second tree. Whenever we encounter a tree, we will check that the first element of the queue is equal to the leaf or not. And if it is equal, we will pop that element out. Otherwise, we will return false. That will check for all the leaves in a same order. Why cannot we do the BFS, breadth first search? Because let's say there are one case in which this is a leaf and there are multiple leaves here, right? So these 3 leaves will come after this leaf because BFS will do a level order search and DFS will do right to left search, right? First it will left to right search, so it will first search in a left part, then it will come to the right part. So this is the basic difference between DFS and BFS. So we have to use BFS, we have to use DFS here only. We cannot use BFS, right? Because we don't want a level order leaves. We want a right to left to right order leaves. So So let's start with the coding part. So as this is a C++. If you want the solution in Python or Java, you can ask me. So this is via Q. We are using DFS. This check is a boolean for it recommend if so. I don't want to write the code for. There are two trees, right? In first tree we have to insert in the queue, and in the second tree we have to check that leaf is similar or not. So I will pass check is equals to false for the first and true is equals to true for the second, right? So if not true we will return true, if not true we will return true. That x false means this is not a leaf, right? This is a leaf, right? So so x means not leaf, not leaf. So if there is a root left, that means this is a not leaf. That means x will become true, and we will check for the DFS of the left part, right? And in any case it will return false, so we will return false. That means in any case the front part of the queue is not equals to the leaf, so the order is not maintained. That means this is not a similar case, so that will return false. Similarly for the right one, we'll do that. And if not x, right, that means if it is a leaf, so we'll do check, right? So check means do we have to check or do we have to insert? So if we don't have to check, we will insert in the list, insert in the queue, otherwise we will check. And if the list is empty and we have encountered a leaf, that means this is not the same case, this is a wrong case, so we will return false. Otherwise we will check that case, the list queue ka front will pop out from the k. Now we will check that the values are equal or not. If the values are not equal, we will return false, otherwise we will do the same thing. And for after this we will return true. That means till here we have done right. So now we will insert in the queue for the tree 1 and we will check for the tree 2. So it is false and it is true, and we'll check if the list is empty, if the queue is empty or not. That means if after iterating through the whole second tree, if there is remaining in the queue, that means there is not a similar leaf. So this is the solution for this question. I will share this solution in the comment section, you can access that. So yeah, this is accepted as a 100% beat. So that's all guys from my side in this video. If you have any doubt, you can ask me in the comment section, as well as you can join the WhatsApp group where you can ask any doubt, right? So that's all from my side. Thank you for your time. Have a good day.